All right, so I'm going to go ahead and start. Welcome. I am excited that you are here with me today. I'm Rita Claire. I'm the author of How's That Human? And I am dressed up as Scientist Fox because I love to dress up. I think being in costume is so much fun and it brings so much more, zest of life out of people sometimes. So I'm very excited that you're here. And we're going to talk about my first book today, How's That Human? Chemistry! All right, well, it isn't a party without some silly string, obviously. And I would like to say silly string is nothing but chemistry. So when we look at what's inside this little can, it's full of liquid. It sounds like liquid, but then it comes out into this like stringy stuff that can be kind of wet and sticky. Well, it's chemistry. There's three parts to what is included in silly string. First of all, there is the polymer itself, which creates the actual colored string that we see. Then there is a surfactant, which is like a sticky substance, which allows the stuff to stick to you. And, spiders actually use a similar kind of surfactant when they produce their silk for their webs, so that it provides that little stickiness to catch their prey. The last and most important part is a propellant. So it is most of what is contained in this can, actually. The polymer, there's a chapter about polymers in my book, and the surfactant are very, very small amounts inside this can. What happens is the propellant is a gas. And gas molecules love to be excited and move around, and they do not like to be trapped. So when you trap gas into a tiny little container, they're still trying to move around and spaz out, and they can't. So it creates this highly pressured situation. Well, when you squeeze the little top, you're releasing all that pressure, and all that gas molecules are ready to expand and run around free. Sorry, gas molecules. You get trapped with that polymer. And that's what kind of gives that foamy texture and squishiness to silly string. So it's kind of like bread. When you cook bread, there's a chemical reaction that occurs that ends up trapping gas molecules inside the bread dough as it rises. And that's why we get that nice air pockets inside all of our bread dough. It's trapped gas. So there's a lot we can do with trapped gas. Anyways, I would love to talk about the cover of the book and, what it really represents about this whole series for me. I wanted to make sure that we could kind of connect with students at their level, like really what's more human than talking about humanity. And these books are going to address what it means to be human from a chemistry perspective, physics perspective, earth science, and space science perspective. So they're interdisciplinary. They combine life science with all other subjects, or they will when we get finished. And I'm very, very proud of what my illustrator did in the book. I think you guys are going to just fall in love with so many of the characters. Nerve Cell, there she is. She's my absolute favorite one. Oh, I just adore her. And what's really great about both the author, me, Rita Claire, just Scientist Fox right now, is that both the illustrator and I are actually scientists. I used to work with viruses, so this pandemic has been very fascinating for me. And she used to work with the mechanics of movement of animals. So I cannot wait to see what she's going to draw for you in the physics book, where we're going to talk about how the physical aspects of how we move as humans. So I'm looking forward to getting that book out to you guys late spring, so be on the lookout.
Okay, and real quick before we dive into the actual book, don't forget the first 10 people to DM How's That Human their address will get a free signed copy of the book.
And I'm so excited. So yes, please, if you're comfortable, don't worry, we're not going to use it for anything but to send you a signed copy of the book. So I'd love to share this with you guys. So just DM us your address. That'd be wonderful. All right, want to get inside the book?
Me first. So my probably favorite parts about the book would be creative corner. It is very fun because you have a project that you can do at your house. Like this one is create your own atom from items around your home. We used pipe cleaners and fuzzballs. My other favorite part about the book would be ready to research. because it gets you to research about the topic. And it also comes with a did you know statement. Like this one is, did you know only four elements of our make up our 96% of our body weight? Like that's just like my favorite character in the book, MG, when his mind gets blown by the topic.
Thanks, Q. One thing I would love to mention is Creative Corner is really for project-based families or people who are looking for the kind of alternative way of showing learning. And in the back of the appendices, I've included over 75 different options for projects. So you could even just show your kid this list and let them pick, an alternative way to show understanding. I really like providing kids with those options.
My turn. Okay, so I'll show you my favorite in the book. So my favorite in this book is definitely the Scientist Spotlight. It shows you what the scientists did in their life and where they are in the world, which is super cool. My other favorite one is Quick Question. It asks you a question about the main idea or the topic or the vocabulary about that section. And it's easy to find and orange and right there.
Awesome. I'm going to tell you guys about the last two categories that I include. Very important as a former working scientist that we had really good ways to show our data. So Data Dive allows the students to look at, representative data of the topic, but in a graphical representation so that they can understand, the types of graphs to use for that type of data, but also how to read the graph. As a teacher of primarily secondary students, middle school age and high school age, I feel like my elementary school students could really use a little more graphical understanding, not only how to get the data, but then what is the actual, best form to represent that data. So I wanted to include that. But of course, having been a practicing scientist, my favorite is the hands-on from home section. So that section, I tried to find and come up with different types of, reactions or experiments that you guys could do from home in a very affordable way. So none of these experiments will require too much of outside purchases. Even for like a classroom teacher, that's great. I know that our budgets are pretty limited, unfortunately. So these experiments are all Next Gen Science Standard aligned. And so if you're concerned about having, the standards represented, they're represented in this whole book. The book does go above and beyond what the chemistry requirements are for elementary school, K through 5. But as, a scientist and as a teacher of science from K through college, 15 years experience, I would say the thing that I would love to see more moving forward is that science education at the elementary age, introducing topics at an earlier age. These kids are capable. They're really, really capable. Kids are so capable. It's awesome. Like, that's what gets me excited. Like, kids are so capable of so many things. So, one last thing I would like to mention is some of the projects from Creative Corner, and then some fun little additional suggestions, usually in like a bright gold circle in the book. Bring the kids to a website. So we created this website to kind of help with the whole pandemic, social distancing, lack of community for kids. I feel that's a huge issue right now. I currently teach homeschool classes. I teach 8 week, which is virtual though, and I just can feel the kids losing that social connection a little bit with the topic. So this website, when you get there, we will end up having different projects, and I have all the pages that show you kind of where this project came from within the book, or the suggestion for it. But there's a discussion board question where they can talk about how they would help people suffering through hypothermia. There's a movie theater. So for those kids who might really want to make film and like slow motion movies, you guys can submit us your anything, like your debate topic, your atom that you made. All of this you can submit to us at howsthathuman.com, submissions at howsthathuman.com, and it can be anonymous, no problem. But that way the kids can go to these and say, oh wow, look at all these other little films other kids my age have made. Wow, that's inspiring, that's cool. Or, oh hey, I like this idea for helping somebody get through hypothermia. Instead, I would do this. So it's a way for them to maybe still foster that community or a sense of relatability to other kids their age statewide, worldwide. I'd love to see, students from worldwide join in on this book. So, all right. I would love to do one of the experiments from the book with you guys.
And this experiment happens to be my favorite one, which is amazing.
Still can't get the stuff off me. All right, so we're just going to rearrange real quick. This experiment in particular is about how we can manipulate or change chemical reactions. So when chemical reactions occur, all the molecules have to line up and bump into each other in the correct manner, and then they go through this reaction. Well, temperature, which is basically a changing of the amount of heat that is in the situation or the system, it can give you more energy if you provide heat. If you take heat away, you take energy away. So when our molecules get heat added, all of a sudden they're normal moving and they're like boing, 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 like they're going crazy. That allows them possibly to hit each other sooner and go through the chemical reaction faster. Conversely, if you slow it down and take temperature away or heat away, they may not actually end up bonking into each other in the right way. So it slows the reaction down. Can we actually visually see this? Yes, we can. So really easy. Dollar store for the win right here. Glow sticks, always good for a party too. Basically what happens when you snap these and you combine the fluids that are in there, you're allowing a chemical reaction to occur and light is emitted, right? That's the cool thing, right? We want to see that light. Well, we can test this theory of can temperature truly affect the rate of reaction or how fast or how slow that reaction goes. And this is one of my favorite ones to do. I do it with K through 12. It's just an easy, fun way to see that temperature can indeed affect the rate of a reaction or how fast it can occur. So we're going to try to do this in a proper scientific manner. We got our cold water bath, our room temperature bath, and our, yes, be very careful, little H-team member. H-team for the humans in my life as my fox self. So very hot water, room temperature, water, cold water. We're all going to get a stick. We're going to need Lightman to come over here and help turn off the lights so that we can see if there's a difference in the chemical reaction. All right, so most of the time as scientists, you try to only change one thing at a time. So for that, we're kind of limited in trying to snap these all at the time, shake them and get all the amazing chemical reaction going at the same time, and then putting it in the beaker at the same time. So those are called controls. We're gonna do our best. But any experiment, you really only want to change one thing at a time. You want to try to keep all the other kind of variables or things that could be changed the same. So we're gonna do our best. So we'll snap them at the same time. We'll give it a couple shakes, make sure the chemical reaction is going, and then we'll insert it all at the same time into these beakers, and then we'll turn off the lights and see what we can see. All right, ready?
3,
2, 1. Okay, 1, 2, 3.
Ooh.
All right. We got one more window. There we go.
There we go.
I feel like we're at a campfire.
I know, right?
Okay, so I'm pretty sure you guys can see that temperature affects the rate of reaction, right? In our steamy hot pot over here, we have a very, very luminous or very, a lot of light. Let's just say a lot of light being released from this chemical reactions going on in this tube. Our room temperature water, still pretty bright, but not at the level of our hot water. And then our poor little cold water situation. Again, all that heat is being taken away, slowing all those molecules down. They can't bonk into each other anymore, or very, very slowly, right? We're at least getting some, because we see some light. But, yep, pretty simple experiment you can do from home within, oh my goodness, 10 seconds?
Yeah.
30 seconds?
Very fast.
So I hope that you try this experiment regardless if you get the book, but please spread the word. I thank you guys for joining us today. I would love to open it up to questions. And I have to say, my shirt, I will add, I have a little winky face. This is actually something that my students have told me a lot of times. As a science teacher, I walk around, I'm like, so explain to me what's going on. And they're like, because science. So I have to say this is a shout out to my former students because I think it's actually very funny and very true statement. Just a little more elaboration needed. Any questions for me or the kiddos? All right. Well, if you haven't already sent us your address for a free book, please do so. I look forward to seeing some, other work and other projects done by other little H team members out there.
Do it.
Yes.
Yeah, definitely.
All right. Thank you all for coming today.
Thank you. Bye.
Bye. Bye.